Yes, he is.
Story and the truth.
Right.
And things are leaning towards his side a great deal. Yeah. Yeah, I think you girls should bake him a cake and give him a car. Yeah.
And we can have it in class?
Yeah. I want to see that. Yeah. Yeah. Okay, let's listen up. Let's go, guys.
All right, everyone. So, hello, happy Thursday. It's almost Friday, but it's not. Good morning, good afternoon. It's that weird time of day. So this is Maven, her life, her story. I'm Kyle, and y'all can introduce yourselves.
Jessica.
Hi guys, I'm Christian.
Hi, I'm Bethany.
And we call ourselves the Retro Gays. And
So we try to go with the cheese.
wait, oh, there's more. So we're gonna pass out pop-ups. They have a striking resemblance to Mars, the planet we'll be focusing on today. This is different. Wait. And this is a fitting soundtrack.
Alright, wait, there was more.
Well, I mean, you guys didn't hear it, but David Bowie asked us an interesting question.
So the song's called Life on Mars, in case you didn't.
Which is, interestingly enough, the same question that Maven is asking. Was there life on Mars? Is there life on Mars? It's interesting that David Bowie asked that approximately 30 years before Maven did. So, something to think about.
Good.
Alright. Okay, so Mars. We just wanted to give you guys a little intro so you know where we're going with this. Mars is the fourth planet from the sun and the second smallest planet in the solar system. She's right behind us, rotating around. She's doing good. And she is named after the Roman god of war and described as the red planet because of the iron oxide prevalent in the surface.
Alright, so what is Maven? Who is she? Mars atmosphere and volatile evolution. Notice the capital N, that's why they have like Maven. I thought that was a little bit creative. Is a space probe developed by NASA designed to study the Martian atmosphere while in orbit. And Maven's goals include determining how the planet's atmosphere and water, presumed to have once been substantial, were lost over time. So we're here to figure that out, so let's see where we go.
And it's important to note Maven was launched in November, so that's why she's a Scorpio. So we think descriptive representation is important, so here's a video of a NASA scientist who is female talking about Maven.
Women in science.
Women in science.
Let's
Sounds
represent.
good.
Let's represent.
Wait, go back.
Play the video.
Yeah.
ratio of chemicals in the upper atmosphere will give us a sense of what happened over the past as well. What we're looking at here is massive and catastrophic climate change on another planet. And I think that people often think that planets are these very permanent, solid things that you can't change very easily. But in fact, climate is always kind of in a balance. And as human beings right now, we're doing a very profound experiment on the Earth, and we're changing the climate. And we're doing that in a system that we don't really understand how the basic physics works yet. Understanding what happened to Mars, I think, is going to give us a better idea of how planets in general change and evolve.
So we're going to kind of break that down for the remainder of the presentation. It's good to have a pro breakdown, and then we can kind of disperse that information out to y'all. Yeah.
Okay, so what's her size?
Maven was built and tested by Lockheed Martin Space Systems. I know you guys are probably familiar with that. Her design is based on those of the Mars Reconnaissance Orbiter and Mars Odyssey spacecraft. The orbiter has a cubical shape of about 2.3 meters by 2.3 meters by 2 meters high. You guys can figure that out in your heads visually. With 2 solar arrays that hold the magnemeters on both ends. The total length of Maven is 11.4 meters.
Okay, so the beginning, how did she get her start? So as we previously mentioned, Maven was launched November 18, 2013. She was launched aboard an Atlas V launch vehicle. And she was launched at this time, kind of like how you guys talked about, like with the Mars 2020 in the previous group, because like the way Earth and Mars were kind of lined up, it would have made like a perfect launch for them. Like by the time it took Maven to get there, she would have been like right in the orbit. Yeah. So she like was coasting low in Earth for like 27 minutes, hanging out, and then she really got going and hit like right into her trajectory to Mars. And she actually never landed on Mars, as they said in the video. She just orbits Mars, kind of checking out the atmosphere.
Okay, so her arrival, how did she get where she needed to go? Let's find out. On September 22nd, 2014, Maven reached Mars and was inserted into an aerocentric elliptic orbit, 6,200 kilometers by 150 kilometers above Mars' surface. And then over here we have him. The principal investigator for the spacecraft is Bruce Jakosky, I want to say, of the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder. So here we go.
Yeah, so telling NASA what she's all about. As you know, the space program's been going through some things lately, but luckily we have this great initiative on Mars still continuing. So on November 5th, 2015, NASA announced that the data from Maven shows the deterioration of Mars' atmosphere increases significantly during the solar storm. So where the scientists kind of hypothesized we'd be seeing this on Maven, Maven is actually bringing back those results, which is fruitful. That loss of atmosphere to space likely played a key role in Mars' shift from its carbon dioxide-dominated atmosphere, which had kept Mars relatively warm, to the cold, dry planet seen today. So whereas there's a lot of life on Earth, which is sustained by our oxygen, luckily we plant some trees, that's not the case on Mars. So just to give you guys a stunning comparison of why it's so such a barren planet. This shift took place between about 4.2 to 3.7 billion years ago. So this is some other things NASA has done. So,
Okay,
yeah,
but wait, she's not done yet. The orbiter is in Mars orbit and operational. The commissioning phase lasted until the first week of November 2014, so about 3 years ago, next month. And then the science phase of the mission commenced. So in June 2015, the science phase was extended through September 2016, and Maven carries enough fuel to extend its science mission for an additional 2 years, and then another 6 years to function as a telecom orbiter at a higher and more circular orbit. So we're just going to keep on learning more information about Mars and whether it's possible that we can actually live there in the future.
Alright, so what's going on with those solar winds? Let's see. So on November 5th, 2015, as we said before, NASA scientists finally reported what they discovered from Maven, which is that the solar wind is, as they predicted, responsible for stripping away the atmosphere of Mars over the years, because as the nice lady said in the video, Mars doesn't have a magnetic field like we do, so they can't deflect those. She can't deflect those solar winds.
Does she lose water? Let's find out. Mars loses water into its thin atmosphere through evaporation. Here we pictured some water droplets. Solar radiation can split the water molecules into their components, hydrogen and oxygen, just like Dr. Rob has taught us with his organic chemistry. The hydrogen, as the lightest element, then tends to rise far up to the highest levels of the Martian atmosphere, where several processes can strip it away into space to be forever lost to the planet.
So what does she use to get the job done? So we compiled a list of resources. So I'm not going to list them off because that'd be rude to you because you can read them all. But let me just go through some. So the solar wind electron analyzer, which measures solar wind and ionosphere electrons. The solar wind ion analyzer measures solar wind and magneto-sheath ion density and velocity, superthermal and thermal ion composition, static, very clever. Solar energetic particle, the Langmuir probe and waves, did I pronounce that correctly? And the magnetometer. So just a few of the resources that our tax dollars are paying for. That's going to help us discover if there's life on Mars. So great, good to go. This is mainly to make sure that you're all paying attention because I realize this is a morning class, so definitely Halloween's coming up. If you want to consider living on Mars, here's some Halloween. Dr. Rob, maybe A. If you want to look like Cher, maybe D. All right, here you go. So. Great, keep going. So we have another video for you really quick.
We're gonna see what's going on.
That's a super long intro.
If you want to send a spacecraft from Earth to Mars, how would you get there? You can't aim straight at the red planet because it's moving around the sun almost 13,000 miles per hour slower than the Earth. Instead, you'll have to wait for up to 26 months for the Earth and Mars to be in just the right spot in their orbits, then carefully aim at a moving target. In November 2013, the controllers of NASA's Mars Atmosphere and Volatile Evolution Mission, or Maven, did just that, launching the Mars-bound